Hi everyone, I hope you had a good break. I've just got a couple of questions from some students, and rather than replying to them individually, I thought I'll just make a little video. Everyone can see it, and yeah, so I hope you had a really good break. Just a reminder, the SAC will be on, part A will be on Friday in our double. Okay, and then on the following Monday will be part B. Was it Monday or Tuesday? Anyway, that next lesson in week 2. So these questions, I'm going to do 2 videos. This one's from Cambridge. Looks like it's some of the Cambridge chapter review questions. So if at any point you want to have a go at them, you haven't seen them before, feel free to stop the video and you can have a go at them before me. But if you've seen them, that's all good too. But yeah, you don't have to watch this. This is just answering some student questions. Okay, so the first one, we've got matrix X. Okay, I haven't used this app since COVID, so it might be a bit rusty, but we'll see how it goes. So we've got matrix X, which is of order PQ, okay, and matrix Y, which is of order QR. So the matrix products X and the inverse of Y, and the inverse of X and Y are both defined. Okay, and then it'll just say for which values of P, Q, and R will this work. So whenever you get these questions, which a little bit like you got, I guess, pro numerals, I would just do a bit of trial and error. I would actually substitute values in and just see what works for you. Okay, there's definitely a matrices especially. That's a really good tactic. So what I'm going to do is, let's zoom in a little bit. But I'm just going to say, so matrix X is P times Q. Okay, and matrix Y is Q times R. Okay, and what I'm going to say is, so obviously X times Y is going to work because the Q and the Q match up, and that's fine. But what I'm going to do is I'm going to say that Q is, I'm going to give it the value of 2. So it's got 2 columns in X, okay, 2 rows in Y. Okay, so obviously that's defined. Now, if we do the inverse of X times Y, that's going to be Q, which I'll undo that. That's going to be now the inverse of X is 2 times P, because remember the rows and the columns swap around, times Y, which is still 2 times R. Okay, so for this to be defined, that means P has to equal 2. Okay, yeah, so P has to equal 2 for that to be defined. Okay, and then if we do the, I went out of order here, but we do X times the inverse of Y. Okay, that'll be P times 2. Okay, and the inverse of Y was R times, we said that Q was 2. So just swapping this around. Okay, so that means if this is to be defined, that R is also equal to R2. Okay, and at the start, we just said that Q was equal to 2. Okay, so all of the values have to be the same. Okay, so I think that answer will be C. Okay, when P equals Q, which equals R. Okay, the next one, just rub that out. We've got a taxi company which has 2 depots at A and B. They always keep X amount of taxis, or X taxis at A and Z taxis at B. The transition matrix T shows how the taxis change their nightly location. Okay, so remember guys, down the diagonal, okay, is them just keeping it. Okay, and the 35% and the 70% is the change. Okay, on a particular night, 14 taxis came from Depot B to Depot A. How many taxis are in that particular fleet? Okay, so this question's based on, I think it's either 2020, maybe 2021. It might even be 2019. 2019, probably 2020 VCAR exam. It's like a question about some planes. And yeah, it's the exact same question. So what I'm going to do is I'm actually do a transition diagram. So we've got depot A. Okay, and we've got depot B. Okay, and we've got transition from A, from B. Okay, and we're obviously keeping some and keeping some at A as well. Okay, so what this question's saying is that B is giving 14 taxis. Okay, and we don't know how many is at B. It says that B has Z amount of taxis. Okay, but we know the percentage from B to A is this 70%. Okay, so what we can do, we can say that 0.7 times Z, the amount at B, will equal to 14. Okay, and we can rearrange that to get the original amount at Z, and that is 20. Okay, I'm just going to rub that out because we need to find the total amount of taxis in the fleet. So this is where this one question, once you just know this part, it makes it easy. But it says in the question that they always keep X amount of taxis at A and Z amount of taxis at B. So essentially, if 14 taxis are leaving B each night, that means that A has to be giving 14 as well. Okay, because it keeps X amount of taxis at A and Z amount of taxis at B. So then we can use this percentage here, and we know that the taxis at A represent as X. Okay, so 35% of our total taxis at location A will equal to this 14 taxis that are being given back. Okay, if we rearrange for that, okay, the amount of taxis at location A are 40. Okay, and now we can answer the question, how many taxis are in the fleet? We've got the 40, we've got the 20. Answer is D. Okay, next question. So a group of people travel every weekday and have a choice of transport, the type of transport they use, so train, bus, or car. They change from day to day according to the transition matrix. Okay, so on Monday, 30% take a car, 70% take a train, and no one takes the bus. Okay, what is the percentage of people who are not expected to change their mode of transport from Tuesday to Wednesday? Okay, so we've got the transition matrix here. Okay, and then we've told Monday, which the Monday the initial state matrix, which I'll use for Monday. Undo that. Is going to be, so I'll just say S0. Okay, so what we've got to do is we've got the Monday percentages. We have to find the Tuesday percentages using the transition matrix here. And then we'll get to the Tuesday from Wednesday part after that. So I'll just put this in order. So this is train, bus, car, just by looking at this here or the other side as well. So the train people are 70%, the bus people are 0%, and the car people are 30%. Okay, so that's the initial state. Okay, so what we're going to do is then we're going to use our transition matrix. I'm going to times that by S0 to get, I'll just write Tuesday people. Okay, so just give me 2 ticks. Sorry, I can't show you there. I've just got my calculator here. So all I'm going to do, you can just fast forward. I'm just going to find the answer for Tuesday. Okay, so for Tuesday, I have 0.605% of people taking the train, 0.215 for the bus, and 0.18 for the the car. Okay, and if you add those percentages, it should equal to 1 as well, which it does. Okay, so now we've got the Tuesday percentages. Okay, the percentage of people who are not expected to change their mode of transport. Okay, so as we said, this is train, bus, and car. And like we said before, down the diagonal is those people staying in that position. So we're going to have 0.605 times, this is going to Wednesday, so 65% of them will stay. Okay, plus we've got around 20% and 10% of them will stay, plus the 0.18 and 25% of them will stay. Okay, so I'll just find that answer. Okay, I get 0.45975. Okay, so the answer is going to be D. Cool. Moving on. Okay, this is the question. Sorry, I haven't actually had a chance to explain it properly to you guys. So if you're still confused with it, we'll do it now. But yeah, with this question, essentially, there's a competition. We've got the one-step dominances, we've got the two-step dominances. And in this question, we're asked to make the one-step matrix, the results matrix. Yeah, just the one-step matrix. Okay, so my 2 tips for this is, my first tip is that the rows is the wins. Okay, and the columns a lot, that's already there. But essentially, no one can beat themselves. Okay, so when you add up these wins and losses, there should be 4 in total. Okay, so that's one tip. And a second tip is that I think it's easiest to start with the people with the least amount of wins, just because it's easier to find out their information. Okay, so like I was saying before, so the wins for Ike should be 3, for Jolene 3, Katie 1, Leslie 1, Mickey 2, which means that when we add their losses, Ike has 3 wins, can't beat themselves, so Ike should have 1 loss, Jolene should have 1 loss, Katie 3 losses, Leslie 3 losses, and Mickey 2 losses. Okay, so yeah, once you start filling in enough, you can use that to find out. Okay, so if we start at the least amount of information, it's either going to be Leslie or Katie. Okay, so we've already got that Katie had to have beaten Leslie because of this this 2-step win. Because it's only one. Essentially, the 1-step means how many they've beaten, and then of the people they've beaten, how many people those people have beaten. Okay, sorry if I haven't explained that very well. But so Katie bet 1 person, and then that person that she beat should have only bet 1 person in total. So that means that Katie had to have beaten Leslie. Okay, which we've already gotten there. Okay, just remember that this matrix is symmetrical. So down the diagonal, it'll mirror. Okay, so if Katie bet Leslie, that means Leslie lost to Katie. So, it's not symmetrical, that'd be the same information, but where there's a 1, mirrored on the other side should be a 0. Okay, And like we were saying, okay, so with this question, there's so many ways to do it. But with Katie, I'm already looking at Katie's column. Katie's got to have 3 losses. So straight away, that's where the ones have to be. I've never done it that way, but yeah. You do it like that. But I'm just going to keep doing it as if it was normal. Sorry, there's no normal way to do this, but so I've done Katie, then we go into Leslie. Okay, so Leslie here has beaten one person. That one person bet 2 people. Okay, so Leslie had to have beaten Mickey because Mickey's the only one with 2 wins. Okay, so Leslie had to have beaten Mickey. Okay, which means Mickey lost to Leslie. Okay. And like I was saying with the rows, so Leslie has 1 win over here. Okay, she's got the 1 win. She's already got that 1 win. That means these are losses. Okay, which if we do symmetry, we've already sort of done those too. Okay, and then from here, I'm just making sure I've got all the symmetrical stuff. I think I have. Okay, now we're going to go on to Mickey. So Mickey has the 1 win. She's beaten Katie. So that's one of these 4-step dominants. That means she had to have beaten Jolene or Ike. Okay, but at the moment, we sort of don't know because they both have 3 wins. So we're just going to leave Mickey for the moment. Okay, Jolene. Jolene has 3 wins. The reason I'm doing Jolene over Ike is because she has the smaller 2-step dominance there. So if I look at Jolene's row, she has the 1 win here against Katie. Okay, and Katie had just 1 win. So of these 4 steps, she's got 1 so far. Okay, now for the 3 wins, it has to be Leslie and Mickey. So the 1 here and the 2, because that's the only way that, because Leslie had 1 win and Mickey had 2 wins, that's the only way that it's going to equal to the 4. Okay, I should do these as pluses. It's getting a bit messy, but so Jolene bet Leslie and Mickey. So Jolene bet Leslie and bet Mickey, which means because this adds to 3, okay, that's a 0 there. Okay, and then from here, you're sort of just filling this out as we go. So Jolene, that means Ike bet Jolene. Okay, and then I've just got these last. I've done the Ike and Leslie. Ike, I'll just do it with a highlighter. Oh, my bad. I just rubbed it out. Sorry. Where's the highlighter? I'm just trying to highlight this 0 here. So Leslie lost to Ike, which means that Ike bet Leslie. This is just that symmetry I was talking about. Okay, that's the 3 wins. So that has to be a 0 there. Okay, and this is that 1 there. So Ike only had 1 loss. That's the 1 there. And what's this one? Mickey and Jolene. Okay, Jolene bet Mickey, and there's the other one. Okay, so yeah, just like I think I did that different to how I've usually done it. There's no right and wrong way to do it. The sack has a similar question, so yeah, feel free to just practice that. Yeah, do that a couple of times, and yeah, you just get used to it. So cool. Okay, last question from this student. A transport company hires 2 types of buses. Has 2 types of buses for hire. So we've got coaches and minibuses. Buses can be hired either per day or per hour. Okay, the cost of hiring each type of bus per hour or per day is shown in the table below. Okay. So the matrix product P that will give us the total cost in dollars of hiring a coach. Okay, so for either 8 hours or for 1 day is shown below. Okay, so we're only looking at the coach. So I'm just going to get rid of them. That's really messy, but get rid of the minibus. Okay, so we can see that 180 and the 920 fits down there. Okay, and then we've got the A and the B. Okay, so we know with matrix multiplication, it's along the rows, the first, down the column of the first. So it's going to be the 180 times the A, then 920 times 0. Then, yeah, along the row, down the column. So the 180 times the 0, 920 times the B. Okay, so essentially A is going to relate to the per hour cost. B is going to relate to the per day cost. Okay, so it says in the question that the coach is going to be hired for 8 hours. So A here is going to be 8. Okay, and then it's going to be 1 day. So B is going to be 1. Cool.